Good afternoon, folks. The first solar impact came 6 hours early. We certainly have much more coming, but here's where things stand right now, and then we'll try to come live later this evening right here on YouTube. The plasma shockwave struck Earth's magnetic field around lunchtime in the United States. It was very fast and moderate density shockwave with a powerful embedded magnetic field. The magnetic disruption to Earth came on much more quickly than anyone anticipated, and that includes me, who knows Earth's magnetic field is weakening. The geoelectric dynamics were furiously amplified in the Western world, and no, this mapping doesn't exist for anywhere else. But it was quite the pulse that we took as the geomagnetic storm reached level 4 just from this first impact, which was probably a combination of the first 2 eruptions, maybe 3. Magnetometer pulse was huge, similar to some of the biggest storms of the last 20 years, and we're just getting started. And instantly, all at the same time, several networks and systems began having issues. These are the local and regional levels we had predicted in the last 2 shows. We will keep tracking this, but if you happen to see any technological news, including power outages, please share them with us here in the comments or on Twitter. So we have 3 or 4 shockwaves still coming. I'll hopefully see you tonight for the live stream. Watch for the announcement on my Twitter page, which is linked below, @SunWeatherman. And I will see you then to answer questions and give another update.
We have a solar storm train of 7 solar storms on their way to Earth, with the promise of lots of aurora and a reminder of the importance of space weather. Those stories and more in this week's Spotlight. Space weather this week remains in high activity mode. As we take a look at our Earth-facing disk, we had been paying attention to region 3663. This had been the big X-flare player. Earlier in the week, it had been firing lots of different X-class flares and other big flares, but it had not been giving us any Earth-directed solar storms. However, as we watched region 3664 and 3668, once they crossed center disk, right around where that hot longitude was, as expected, they started to grow. In fact, region 3664 began to merge with region 3668 late on the 7th and into the 8th, and that is when all the fireworks really began to start. In fact, right about the 8th, you see this region right in here began to fire off a solar storm, and then it fired off another solar storm back to back right here. Those were 2 storms, and then it launched one more storm right here. And if we take a look in coronagraphs, you can actually see the first solar storm right here. This is the one that's going mainly southwest of Earth, but that's still partly Earth-directed, so that's storm 1. Then shortly after that, right on its tail, you see a big halo. This is a totally Earth-directed solar storm. That was the first big X-class flare from region 3664. And then shortly thereafter, we had yet another halo, bam, right there. That is now storm number 3 that's headed toward Earth. And yet this region was not done. As it continued to move, we actually got more activity from it, but not before it fires off a filament right here off to the west, slightly northwest of Earth. But at this nearly the same time, we got yet another big flare from this region. So we have yet another 1-2 from solar storms, and then we had a short one that came after that as well. But take a look in coronagraphs. Here is the partial halo from this filament eruption that's going mainly to the east of Earth. So what is that? Storm number 4 now. And then shortly thereafter, look, there's another big halo. So that is now storm number 5. But we're still not done. In fact, as we continue this ride, you'll actually see the part of that filament or part of that eruption pop off right there. Now, as we move into the 9th, we're going to have yet 2 more big solar storms. We have a big X-class flare coming up right about here. Bam, right there. That's a big X-class flare. And with that, we have yet another big halo. This is storm number 6. So if you keep them counting, we've got a ton of solar storms all being rapid fired at Earth. And then shortly thereafter, as this region rotates a little bit further to the west limb, you see yet a bam right there, another solar storm launch. And this one has yet another halo. You can see it. It looks like we're finally getting to a point where this region's going to be rotating basically out of the Earth strike zone here soon. So hopefully That's just 7 solar storms. We're not going to get any more Earth-directed solar storms from this region. Can't promise that, but there'll be more flanking blows rather than big direct hits. Now, thank goodness for that, but despite that, we still have other regions on the east limb. If you recall, we have some far-sighted regions that are going to be rotating into Earth view. In fact, as we take a look at our JSOC HMI helioseismology far-sighted viewer, do you guys remember regions 3645, 3654, and region 3644 and 48? These were regions that were giving us big solar flares about 2 weeks ago, and they have all survived their far-sighted passage. You can see in the gold here, this is the far side of the sun, and they're about to rotate back into Earth view. The dark regions show where those sunspot clusters are. So get ready, because we're going to be having possibly more activity to returning into Earth view, giving us more big solar flares and possibly the chance for big solar storms again. So even with region 3664 going off of the east or the west limb, we're still going to be having quite a bit of activity. So aurora photographers, get ready, and amateur radio operators and emergency responders, expect that you're going to still have issues on Earth's day side with those big radio bands, because those big solar flares just aren't going away.
All right, thank you, Erica. Thank you, Sandy. Welcome, everybody. As I mentioned, I'm Sean, service coordinator here at the Space Weather Prediction Center, and we decided to hold this because we have a very rare event on our hand. The last time that we issued a G4 watch, which is a geomagnetic storm watch for severe levels, that 4 level on our 1 through 5 scale was 2005. We have a high confidence that a series of coronal mass ejections, which are blasts of energetic particles and magnetic fields that depart the sun, are directed right towards Earth. Some are catching up with other ones. So our level of confidence is high that we will have an arrival of this CME, or the beginning of these CMEs, as early as this evening, Eastern Daylight Time, kind of later in the evening perhaps. But the timing is, there's less certainty with the timing, so keep that in mind. The level of response could mean that there could be some infrastructure effects, but we have notified all of our infrastructure operators that we coordinate with, such as satellite operators, communication folks, satellite operators, and of course the power grid here in North America. So they are able and prepared to take mitigation efforts as much as possible throughout this event if it should unfold to the levels that we currently are anticipating. Also know that these levels, it does take things that we don't know yet to get to the severe levels on this scale. By that I mean we won't know until these CMEs arrive about 1 million miles from Earth at our NASA ACE satellite and our Discover NOAA satellite that monitors solar wind conditions. That's how we identify the arrival of these 1 million miles from Earth. At that point, when we see the CMEs arrive at the satellite, that's when we will know the intensity that may develop here at Earth by different things in the solar wind that we look for. That's when we'll have more certainty, and that's when we'll begin to issue warnings. So with the speed of these events, roughly we're talking an average speed here of around 800 kilometers per second. That basically means there could be about 20 minutes to 45 minutes of lead time given the variances in the potential speed of these arrival of these CMEs. When I say CME, I'm saying short for coronal mass ejection. The reason for all this is a giant, well, there's been 2 sunspot clusters, one in the northern hemisphere of the sun, one in the southern hemisphere of the sun. So even prior to Wednesday, we were experiencing a large number of solar flares. These are blasts of strong energy that come from the sun, and we detect these with one of our satellites here near Earth, one of the GOES satellites, and we measure those in X-ray flux strength. And we've been reaching the R1 levels quite frequently, R2 levels a lot, and even R3 levels on our scale, so that's into the strong realm. Beginning Wednesday, another sunspot cluster, that one was the northern hemisphere, and that's since rotated to and beyond the limb, but since then we've had another sunspot cluster develop that is one of the largest ones and more complex ones that we've seen in the solar cycle, perhaps the most complex so far this cycle. And that region has begun producing flares as well, which was not unexpected. We've been expecting our probability has been continuing to go up. throughout the latter part of this week. And sure enough, we've been having these flares and now the coronal mass ejections that can sometimes be associated with these. Additionally, one other piece of information I'll throw out there that has just happened is our NOAA Space Weather Scale covers 3 categories. One is HF radio blackouts, which is associated with solar flares. Of course, the geomagnetic storms that you're familiar with, the G scale, and then one called solar radiation storms, which is the S scale. We've been expecting that the region here is likely to produce a solar radiation storm at the S1 levels. That just happened. A warning just went out for that because it's in a favorable location now for arrival of some particles here at Earth. What does that mean? Not too much. That's the fairly low end of our scale. It does mean thing to some rocket launch operations and satellite operators, but at this point in time, it's nothing that can't be handled as far as we understand it. But the potential for stronger events, of course, does exist, and we'll see if any materialize. With that, I think I've given you the lowdown of everything that I want to bring up to you. The key point here is that critical infrastructure operators have been notified that this is the first G4 watch we've issued since 2005, and that the activity is not over. The region is rotating as the sun rotates, so although it's becoming, it did produce another coronal mass ejection overnight associated with another flare that we had at the R3 levels. That one is being analyzed now to see if there's any Earth-directed component to that, and I say that because as the region rotates, it becomes in a less favorable position to have a CME arrive and aim directly here at Earth. The other ones were aimed directly at Earth. However, it becomes more favorable for these radiation storms, which we are now beginning to see develop.
Far more beautiful will be falling out of the sky tonight. Supercharged particles from a massive solar storm. Those will slam into Earth's upper atmosphere tonight, firing up the aurora borealis.
My favorite things. This is going to be one of the strongest such storms in a decade, and that does mean millions of sky watchers across the lower 48 could actually get a view of the light show. That is if the clouds cooperate. And that's always the caveat, right? And
yes,
you've experienced it. I've experienced it to some degree. If the clouds work in your favor, this is an absolutely beautiful thing to see.
I know you're not trying to rub it in, but I can feel the joy in your voice because you got to experience this. Cloud cover spoiled my experience, but you see some scenes of it. We're already starting to see some pictures coming in as this solar storm has gotten started. But yes, you get these charged particles. Earth's magnetic field shields much of the planet, but they get directed around the field and into the poles where they start interacting with the atmosphere.
Right, and that is why you have to kind of head either farther north or far south to kind of see it to the poles, because those have the better chances of getting a good glimpse of it. I love that we kind of broke this down because being out and seeing this gives me more context of what I actually was seeing, right?
Yeah.
The type of molecules that we were seeing, I got a chance to see both green and pink as well as even red and green. So technically I've seen oxygen and nitrogen molecules. I'm not rubbing it in, I promise.
I don't need the balloon anymore. But toss that over there. What's most important here, because yes, we're talking about a lot of places where you're like, wait a minute, the northern lights, yes, way far off to the south, unless, of course, you have overcast skies. You're not seeing anything anyway. Some areas, though, Kiana, all the way down to KC, Denver, you're in pretty good shape.
Yeah, and again, another thing to mention, if you're in these big cities, say New York, I know it says good, but you may have to head a little farther outside of the city. That light pollution could skew your view a little bit.
Yeah, so if you're out in a rural spot and you look up and you can see stars, you might be in for a treat moving through the weekend as this solar storm is up close to historic territory.
Take a picture and send it to us here at Fox Weather.